So this is a piece of advice that you really shouldn't follow. Hello everyone, my name is Wojciech and you're watching Nonconformist. This is the first part of the series when I'll be telling you about computer science, software development and IT in general, and hopefully trying to explain how some of those things work under the hood. And for the first part, I figured it will be beneficial to show you why this kind of knowledge may prove useful. So internet is littered with different pieces of advice. People tell you to create files, delete files, modify registry entries, and do a lot of other weird things to improve your performance of your computer, improve the way your computer works. And truth be told, I think that a lot of these advices are really, really wrong. So some time ago, I was scrolling through YouTube Shorts and I was presented with quite professionally recorded 1 minute piece of advice, which looks legit, but if you think about it a little bit longer, it is really, really wrong. And what I would like to do today is to watch this advice with you, then take it apart and try to figure out what is actually wrong inside. Let's start by watching the full advice. You'll find the link to original video in the description.
Here's a Windows feature that Google doesn't want you to know that could slow down your computer a lot. It doesn't matter what you do, play video games or edit spreadsheets. And I'm going to show you exactly how to avoid it. Video here, my name is Arsen, I'm based in the United States and I help people to get the most out of their task. The first thing that I want you to do is to go to your computer or laptop and press and hold Control Shift and press Escape. That's going to open up the Task Manager. The first thing that I want you to do is to go to your Performance tab and take a look at your CPU usage and the memory usage. I've got to admit, I've got a really beefy computer, but most of you don't, and most of you will be affected by this. What I want you to do next is to go to your detail. Take a look at my Chrome browser. Do you think it's open? No, it's not. Now take a look at my details. Look how many instances of Chrome things that I have open over here, and look how much RAM I'm using, 6 GB. If you don't intend to use Chrome right now, do this and kill the process tree. Even when you think Chrome is closed, it's using a lot of resources. Sometimes when you right click and do the process tree, things will not close automatically, so just try with the next one. Chrome thinks it's important enough to load itself into your memory and take up precious CPU resources.
Even though it is a YouTube short, so it's like roughly 1 minute long, there are a lot of things going on there. So let's start from the beginning. So there's a feature in Windows that Google supposedly doesn't want you to know that makes performance of your computer really bad. We are talking about the Windows feature that is present in this operating system at least since Windows 95. It probably was also present in Windows 3.11 and earlier versions, so this is a history 28 years long. It is hard to believe that Google doesn't want you to know about it because this is a very obvious feature. So unless there's a shred of evidence that really supports the claim that Google doesn't want you to know about Windows features, we have to classify it as a very cheap clickbait. Sorry. Let's take advantage of the situation to learn something new. So let me tell you more about Task Manager. First of all, there are at least 4 different ways you can invoke the Task Manager, which makes it really not that hidden tool. First one is obviously, as you have seen in the video, pressing Ctrl-Shift-Escape. The second is you can right-click on a taskbar and simply select Task Manager. Thirdly, you can use a shortcut Windows X, which opens a kinda hidden, let's call it this way, menu over the Start menu, containing some maybe a little bit more administrative tools, and it also contains Task Manager. And finally, you can press combination of Ctrl-Alt-Delete, which enters a specific mode in the system, which allows you to do some things in case something goes wrong. And among others, it also allows you to open the Task Manager. One of the main purposes of Task Manager is to show you the list of running processes. And you can think of a process as a program which was loaded into memory and is running and interacts with operating system and is also managed by the operating system. You might be used to the fact that programs do have graphical user interface, so they have windows with which you can interact with them. But this is not necessarily required for a program to be running. So as a software developer, I can tell you I can write a program which will be running, which will, for instance, periodically download a file from the internet and save it to a drive somewhere, and it will have no graphical user interface. It won't have any windows, but it still will be working. All the processes shown in Task Manager window are divided into three main categories. The first category are applications. And applications are those processes that actually do have graphical user interface, so they probably have a window. And those are, for instance, Word, Excel, Games, Explorer, Windows, you name it. The second category are those processes which do not have graphical user interface and they are just running in background. What it means is that they are loaded into memory, they are running, but you cannot see immediately any effects of them running. And the third category are the system processes. And these are the ones that actually make Windows an operating system, because operating system consists of a lot of moving parts that work together so that you can use your computer. And to give you some examples, there are processes which maintain the registry, there are processes which take care of networking and various aspects of networking, so connecting your computer to networks and to the internet by extension. There are processes that manage your printer, there are processes that manage fonts, and a lot of other things that are just needed in your operating system. Except only for showing the list of running processes, Task Manager also allows you to inspect how much system resources every process is currently occupying. And there are four main system resources that can be consumed by a process. The first system resource is computational power, or more precisely computational time of your processor. Processors are not really very good at doing a lot of things at the same time, and definitely not as many as there are running processes in your system. What the operating system does is it allocates time for every process during which this process can perform its tasks. It is given the computational power of the processor. When this time elapses, the process is suspended, the next process is resumed, and it can do what it needs. Now, keep in mind, it happens really, really fast. So fast that you have a illusion of processes running in parallel. They are not running in parallel, they're running in sequence, but this sequence is like very, very fast. But the obvious consequence is that this time is limited, and the operating system has to decide how much time to give to every process. And there are multiple factors, but one of the most important factor is how much time process really needs. So for instance, if your browser is in the background, it probably won't consume too much computational power because it has loaded all the pages, displayed them, you are not interacting with it, so it just like hangs in there and does not too much. But if you start opening new pages, maybe run a game in a browser, then it will increase its requirements for computational power, and the operating system will notice it and will give more computational time for this application. The second system resource is memory. Every process is allowed to allocate some memory and store its data inside. And the reason for that is that interacting with data stored in RAM is a lot faster than interacting with data stored on the drive, even if it is SSD. So if you start Word and load a text document, it is actually loaded from the drive into memory, and Word works on it in memory, and this is also why you have to click explicitly save to move it from the memory into drive again. We have to remember though that amount of memory is finite. You might have 8, 16, 24, maybe 32 gigabytes of RAM, but it may run out at some point. And to counter this problem, because it is a serious problem, operating system performs a procedure called swapping. And how does it work? So imagine that we run a process A some time ago, and it puts some data in the memory. And then we're currently starting process B, which requests some memory to be allocated. And operating system sees that there is not enough free memory for this operation to happen. So what it does, it takes some data that was allocated earlier by process A and stores this data on a drive. And then it frees this memory and gives it to process B, and process B puts some of its data inside. But then when computational time is given to process A again, and process A actually wants to access the data that was stored in there, the operating system performs this process again. So takes the data stored by process B, stores it on a drive, and then restores data that was originally put there by process A and puts it back in memory so that process A can work with it. And this works generally the way as it sounds. So operating system juggles data between memory and the drive. And as you can imagine, it is slow. The process itself is slow, but also writing data to drive and reading data from drive is slow because drives, even SSDs, are slower than your RAM, than your memory. So if you want to keep the performance level of your computer at very good level, then you have to avoid swapping at all costs. And there are two main ways you can do that. The first one is you can figure out which processes occupy a lot of memory and then close those processes to free the memory so other processes can use it. And the second way is a lot simpler. You can just buy more RAM and install it in your computer. The other two system resources are disk writes and reads and network writes and reads. And it translates into how much data a process is reading from your drives and writing to your drives, and how much data is it transmitting through the network, either to other computers in your network or to the internet. They also can influence performance of your computer, but not as much as CPU and memory usage. And the final thing about the task manager is that you probably shouldn't be using it too much. So the operating system is really smart regarding to allocating system resources to various processes. And usually, when you try to start fixing things related to system resources, usually you're actually breaking things because you are interfering with the way system allocates those resources, and usually it ends up really badly. So if everything works correctly, if applications are doing what they are supposed to, and you're experiencing no performance drops, then you probably shouldn't be messing around with Task Manager because there is no point in doing so. So if your car just runs, then there is no point in stopping and opening the hood to see what's inside because it just runs. Well, just use it, right? So now, richer with new knowledge, let's get back to analysis of our video. The next thing we see in the video is that there are a lot of Chrome processes running without the Chrome browser running, so the process that has a graphical user interface you can interact with, aka your browser. And this is actually absolutely normal. So if you take a look at, if you open the Task Manager and take a look at the processes that are running, actually majority of them doesn't have user interface. Majority of them are running in the background. But then the question arises, why? And the answer is actually quite simple. You might have installed Chrome applications or Chrome extensions that are meant to be running in the background and collecting some information for you. For instance, data from RSS channels or stock prices or weather. They are just designed to run in the background and collect this information for you. There's an obvious follow-up question, which is, do we want them to be running? And this is the question that you have to answer yourself, because maybe you have some extensions that you really want to be running in the background and collecting information for you, in which case blindly killing the processes will obviously stop that from working, and this is not what we want to achieve. And on the other hand, if you really believe that those processes hinders performance of your PC, maybe this is the case, maybe not. But if it is the case, then you can just simply review the list of your extensions and applications installed inside Chrome, review them, and then pick ones that you can sacrifice and just disable or uninstall them. And there's also an option in Google Chrome which allows you to disable all of them simultaneously. So you can just tell Chrome that you do not allow it to work in background when it is closed, and it will not. Which is, funnily enough, an argument against Google not wanting you to know about it because it is explicitly available in Chrome settings. So the gentleman in the video claims that this feature, Google's feature, may slow down your computer a lot. And I'm not really that convinced. So if you take a look at the numbers displayed in Task Manager in the video, you will see that the processor is occupied roughly 1 to 2%. And this is an indication of system idling. So usually it means that mostly the system processes are running and not very much else. So it's hard to say that those Chrome processes are really consuming computational power. The memory is a different story because those processes occupy approximately 600 megabytes. However, if you think about it, if your computer has 8 gigabytes of RAM, which is kind of rare nowadays. Usually we have 16, but let's assume that we have 8. Those 600 megabytes are roughly 7% of whole your memory. This is not really much. I would say that this is a maybe not negligible, but quite a small number. And if you have 16 gigabytes of RAM, then this number shrinks to 4%, which is even smaller. So this is probably quite a small price to pay to allow some applications running, which probably gives you some benefit. If we are at the topic of memory, I observed a general trend towards having as much free memory as humanly possible. And funnily enough, this is actually wrong. Let me tell you why. So imagine you are carrying a notebook with you in which you can write down things that you don't want to remember. You want to be able to recall them easily afterwards. If you insist on having as many blank pages as humanly possible, then you will quickly see that it is pointless to have this notebook with you because you don't carry any information in it. Every time you write something down and you come home, you rip this page and replace it with an empty one. And next time when you're somewhere out and want to recall things, then you figure, okay, I have only blank pages. It makes no sense. And it is actually quite very similar with the memory. So memory, the RAM in your computer, and RAM goes to random access memory, is the fastest medium in terms of memory of data transfer that you have in your computer. To give you an example, I looked up the cheapest possible memory, the cheapest possible RAM, and the most expensive SSD drive. And the most expensive SSD drive, which costs roughly 2/3 of the laptop that I own, has a write transfer rate of 7 gigabytes per second. And at the same time, the slowest possible DDR4 memory, which costs 56 PLN, which goes around $16 or $15, has a transfer rate of 19 gigabytes. And this is the slowest possible memory. So it is more than twice as fast as this SSD drive. So you have this medium in your computer, which is really, really, really fast. And you actually want to have as much things in there as possible, because your computer will be able to reach them very quickly, far quicker even than your SSD, which itself is very, very fast. Let me tell you a story. So when Windows XP was released, Microsoft included inside a mechanism called Windows Prefetch. And people very quickly started figuring out that this Windows Prefetch mechanism consumes a lot of RAM. And immediately in the internet, people started writing guides how to turn this feature off using some registry settings or maybe configuration file settings. So what Windows Prefetch did was to collect information about the programs that you use very frequently and the files documents that you open very frequently, and it actually preloaded it when your computer booted up so that those things were already in the memory. And the consequence of that was that if you wanted to open the document, it was very fast because this document was already in RAM. And remember that we are talking about times when SSD drives were really not a thing. You would have an HDD drive, which was mechanic, and it was a lot slower than SSD. So loading up file from drive was far slower than having this file already in the memory. But then people said, okay, they are in the memory, I can reach them, but what about if I want to have something else in memory? So I want to start up a game which needs a lot of RAM, and this RAM is already occupied by those documents that I currently don't need. And this was an argument for disabling this prefetch mechanism. Well, the problem is, system was that smart already. So if you wanted to start a game that required a lot of RAM, system automatically freed up memory consumed by this prefetch, and freeing up memory is quite a quick task. It takes like milliseconds, if not less, microseconds actually. And it freed up immediately this memory consumed by prefetch and made it available to the game. But this is something that happened behind the scenes. People didn't see that. People was sure that this mechanism consumes and keeps this memory all the time and not allows it to be reused for other applications. And this is why those advices started showing to disable it. But what really happened if you disabled prefetch is that system stopped preloading things into memory. So every time you wanted to start an application, every time you wanted to open a document that you open frequently, it had to be loaded from HDD. So this advice that supposedly was making your computer better because it freed memory occupied by prefetch, made your computer run slower because the things that could have been already in the memory had to be loaded every time. Now, you may argue that this example is wrong in this case because Chrome is not a part of the operating system and those processes occupy memory for the whole time. And this is true, but what I would like to tell you is to avoid something that software developers call premature optimization. So premature optimization is when someone tries to optimize things, tries to make things better if it is not needed. And the outcome of premature optimization usually is deterioration of something that already works. And this is exactly the case. It might be exactly the case, to be precise. So the first thing you have to do is to figure out if your computer runs slowly, are those Chrome processes really the source of your problem? Because if they are, then you have to take care of them. But maybe this is something else that consumes memory and consumes your processing power, and this is what you have to take a look at. Or maybe there's a physical damage in your computer that causes that. There are a million reasons that this may be happening. So the first thing you have to do is figure out what is the actual reason and then try to remedy that and not just blindly kill Chrome processes when your computer starts. And if we're at it, killing Chrome processes is actually wrong solution to this problem, and wrong for two reasons. The first reason is that killing process is not really a good thing. When you kill a process, you tell the operating system to terminate it immediately as soon as possible. And this feature is actually sometimes needed because sometimes process hangs or starts behaving erratically and you have to terminate it immediately to restrict the damage that it can cause. But when you force the operating system to terminate the process, it is stopped in the middle of what it was doing. So now imagine that those Chrome processes were actually writing some configuration files or some data to the drive, and you terminated them in the middle. Then obviously this data will be damaged. And the second reason that this solution is wrong is that terminating process is the solution for now. If you restart your computer and the Chrome restarts in the background, all those processes will be back. So if you want to follow this advice, you will have to kill those processes every single time you start your computer, and this is obviously not a solution. A lot better solution is just to configure Chrome in a way that it will not run in the background. I claimed that the presented advice is wrong. So what I would advise you to do instead? Firstly, figure out if it is really a problem for you. So it sounded really dramatic that it may hinder performance of your computer a lot, but I really don't believe that. I think it will affect your computer slightly, if at all. So figure out if you really need to do anything about it. If you do, then instead of just blindly killing processes, go through extensions and applications installed in your Chrome browser and figure out which ones you really don't need, and then just uninstall or disable them. And finally, if you want to get rid of all those processes, then simply flip a switch in Chrome settings and you're done. I really hope you enjoyed and I hope you learned something today. We'll see each other next time. My name is Wojciech and this was Nonconformist.